Gravity provides an acceleration that always tells us which way down is, and accelerometers can measure that acceleration. In an IMU, there are 3 accelerometers at right angles to each other, so that they can measure the acceleration in the x, the y, and the z directions simultaneously. If we calibrate the accelerometers when we know we're experiencing acceleration only due to gravity, like when we're sitting on the ground, then we can use the knowledge of which way gravity is pointing as a reference for the gyroscopes to figure out our attitude. So the accelerometers give us a way to figure out which way down is, using gravity as a reference, and then we can use the gyros to figure out what the attitude of the vehicle must be, even when we're accelerating in other directions, and when we no longer have a clean reference to gravity. The original IMUs used for flight actually had spinning tops and springs serving as the gyros and accelerometers. But now, with advances in technology, we're able to make very small IMUs that don't have spinning tops for gyroscopes or complicated springs for accelerometers. In fact, one of the big advances in IMU technology in the last 20 years is the advent of micro-electromechanical systems, or MEMS, that basically allow us to put the equivalent of 3 spinning tops and 3 accelerometers onto a tiny chip and put it inside small consumer electronics like a drone autopilot or your smartphone. So, now that we have the IMU that allows us to work out our attitude, then we can use the autopilot to adjust the thrust of the various propellers in order to move in the direction that we want. But how do we actually know where we are, or how we're making progress toward our destination? Well, there are many options, but the easiest way to measure position is simply with a GPS receiver.